Okay. You like it up here? It's nice. You know, a lot of toys and things like that. All right. So what we found out in this chapter is called reactions in an aqueous solution, right? And a lot of chemistry does take place in an aqueous solution. So the lab I have planned for you, several of those reactions are in aqueous solutions. All right, what we found out was that one of the kind of reactions we have is called a double replacement. Remember how we did that? And we said that the double replacement that we were talking about here, what was the driving force? What is that made the reaction take place? Anybody know that? What is that? Just because on paper, like for example, here's what we did last week. We said lead to nitrate. Whoa. Okay. Oh, you don't like that? That one? Sorry. All right, so we said lead 2 nitrate, aqueous, reacts with sodium iodide, aqueous. But is that really going to happen? Last chapter, we would have done this and we would have said, oh, it looks like double replacement. I think the two products are going to be lead 2 iodide and sodium nitrate. A little switchy, right? And he'd say, okay, but is it going to happen? What's going to make this happen? Let's see if you remember. Max, what do you think? What's going to make this happen? Is it going to happen, you think, or not? Is this reaction going to happen? He said, well, I need one of my tools. I need you have these, what's this for? This is for a double replacement reaction, and I don't need it for the reactants. I already know they're aqueous, don't I? What am I looking for here? Double replacement reaction. I look at the products. What am I looking for? Jonathan, you know. One more time. How do you know if it's going to be a solid? Okay, and a definition for an insoluble product. We're looking for an insoluble product, right? And if it's insoluble, you will see it, won't you? If I don't dissolve in water, I'm going to see you. And that's called a precipitate, right? So look at it here. See there here? We look at these two up, and we look for lead 2 iodide, and we look for sodium nitrate. And I told you last week, you don't have to memorize this chart. I'll give it to you. But guess what? If you can memorize a few things, it'll save you a lot of time. What did we find out last week? That, except for this one, right? Essentially, all acetates are what? All acetates are what? Now, when I say salt, does everybody know what that means? It's an ionic compound. It'd be like sodium acetate, potassium acetate, iron acetate. All acetates are soluble. What else do we know? Something you can remember so you don't have to look it up all the time. What else? What other patterns you see here? Somebody else. I know I haven't seen you for a while. What's something else? Go this way. Go this way. I thought we did this in class. Yes. Nitrates? Okay, look at nitrates. Hey, you know what? I'm not going to look that up. I know all nitrates are soluble. All right, what else? John, you remember him? Did you mark him on your paper? All right, let's say chlorate. Nice. Now, chlorate. Look at that. Good job. Chlorate's soluble. How about something else? A couple more. 3, I think there are 3 more that were real obvious. Yes, Caroline. Chlorides. Now, chlorides, I have to be careful because no and no and no and no and no. So I would say be careful. I'd say a lot of chlorides are, but I probably have to look it up because there are at least 5 exceptions. What's another one that seems to have no exceptions? Yes. Okay, potassium. We're going to go this way. See this? All potassium salts are soluble. Another one. Sodium. All sodium salts are soluble. One more. One more. Let me see if it's on here. Yeah, it's up there. Near the top, yes. Yes. Ammonium salts are soluble. So, all I'm asking you to do is, if you could remember I'll give you the chart, but to save you time on the test. Now, even though I have the test planned for this Friday, we're going to see how it works. We should be in pretty good shape, but we'll see. The worst case scenario is I have to move it to Monday. Everybody get that? So test either Friday or Monday. We'll see. Okay. Well, anyway, if you could remember these, you won't have to look up every single thing. So if I go back over here and I look at these two products, which one do I not have to look up? See, all sodium salts are soluble and all nitrates are soluble, so I know I'm going to put AQ after that. Now, what does it mean? Will I see this stuff? Look at me. Look at my eyes. Will you see this or not? No, it's soluble in water. It's going to be a bunch of ions floating around. You see that? Now, what about this? The chart says S, solid. That's a precipitate. And I will see that. And that's the driving force. The formation of a what? I always ask this on tests. What are the four driving forces? Formation of solid, formation of water. That means new water. And formation of a gas, and one more. Transfer electrons, and that's the hard part of the chapter. But I'm not ready for that yet. Now, here's a skill that every chemistry student knows. Certainly honors chemistry students know this. I'm going to write out this whole thing. That just so happens on page 175. Your author likes to call that the molecular equation. I will just call it the chemical equation. That's the regular old chemical equation. You get that? Okay, so here, I wrote the whole chemical equation out, and I balanced it. Everybody knows how to balance, right? Now, this is the one, I will ask you to do this on the test. Show me that you can give me what they call a complete ionic equation. All right, how do we do this again? I want you to think. This is what makes this chapter hard. What's in this beaker? What's in that beaker? And the author did it over and over. He had a bunch of beakers with a bunch of balls in them, didn't he? What's in that beaker? Not lead, but what? What form of lead? This is lead 2 nitrate. So what's in that beaker? Lead what? It's not lead like the metal lead. The metal lead is lead 0. This is lead with a +2, and it's soluble in water, isn't it? So it's a lead 2 ion. And what else? For every one of those ions, you get what? 2 nitrates. Not diatomic nitrate. No. This is one of those and 2 of those. And that's aqueous. What's over here in this beaker? Not sodium, but sodium what? +1 ions, aren't they? And plus what else? 2 iodine ions, right? I know iodine can be diatomic when it's by itself, but this is not iodine. This is the iodine, isn't it? This is the ion of iodine. Okay, now, what happens over here? You get 2 sodium ions, aqueous, plus 2 nitrates, aqueous. But then what about this guy? You say, I know how to play this game. One of those and 2. No, you're wrong. Why do I not split this one up? Who wins? When these bump into these, who wins? Sodium's ability to hang on to nitrate or water's ability to pull them apart? Who wins with sodium nitrate? Water wins or sodium nitrate wins? Water wins. That's why it's aqueous. What about the ability of lead 2 to hang on to iodide ions? Who wins? Water or lead and iodide? We win. You can't pull us apart. We're insoluble. You can't pull us apart. We win. And so what's my driving force here? Look again. I can't get rid of my driving force, and that has S after it. Doesn't that mean solid? Everybody got it? And I thought the fun part, I don't know if the bell was ringing or whatever at the end of the period, but here's the fun part. Did you know that not all these ions were involved in chemistry? Some of them were exactly the same before the reaction took place as after. And they're called spectator ions. And so scan. On the left-hand side, I see 2 nitrates. On the right-hand side, hey, what did you do? Nothing. We just stood around watching everybody else do something. Well, I'm crossing you out. What about lead? Did you do something? I did something. Okay, I'll come back to you later. Well, what about sodium? What did you do? 2 sodium ions? Nothing. You're out of here. And so what is the only chemistry that happened? Lead 2 ions bumped into 2 iodide ions and formed lead 2 iodide. That's the only chemistry that took place. I'm looking at your faces. I know last chapter, it was just kind of fun. Double replacement, balance, okay, that was fun. But now we're getting to that next level is, how do you even know this reaction is going to take place? And if it is, how do you know which one of these formed a yellow precipitate we saw in the beaker? That's him. And how do I know that? I use my little tool. Use that tool right there. All right, let's try another one. I will give you a reaction that's in the book, and you can see if you can write out the chemical equation, net ionic equation, complete ionic equation, and net ionic equation. Here we go. And then I'll show you a shortcut. Oh, shortcut. All right, let's go on page 173. Here's what I'm going to do. We're going to do B. Okay, here it is right here. I'll let everybody see it. We're going to do, on your paper, I'll magnify a little bit here. All right, let's do B. Sodium sulfate aqueous is going to react with lead 2 nitrate aqueous. And the question is, go ahead and write out the entire chemical equation with the symbols like AQ. Then write out the complete ionic equation, and then write out the net ionic equation. If you can do that in the next 2 minutes, you are way, way ahead of the game. All right, let's take 2 minutes. Anything start now? 2 minutes. I'm going to mute that for a minute so I can write the answer down. Are you getting a little comfortable? A little more comfortable with this or not? And if you hit a little bump in the road, we'll be able to fix that. We should be able to fix that today. possible you have some little gaps, and you said, I got stuck here. It's okay. If you got stuck, you're all right. All right. Elizabeth, you're going to do it. You can do it. Elizabeth's going to take us through the whole thing. Elizabeth, I wrote these down, and I wrote down these. Is that what you had as your products or not? Did you have this? Oh, you're right. Do you have this as your products?
Yes.
And did you balance the equation?
Yes, I did.
Did you have a 2 there?
Yes.
And everything else okay? Okay, now as loud as you can, in a nice clear voice, tell me how to write the complete ionic equation. Oh, wait a minute, I forgot. What symbol do I put after here, and what symbol do I put after here?
It should be aqueous after sodium nitrate.
How'd you know that?
Because I looked at my chart.
Did you have to look up a chart for nitrate?
No, because they're all aqueous.
That's right. That'll save you some time.
For the next one, I put solid.
Is that what the chart said?
Yes.
Okay, so it's a precipitate, right? Okay, now, go ahead, I'm ready. Go.
I had 2 sodium
Wait a minute. Why didn't you write Na with a subscript 2?
because you don't have to.
This is not diatomic sodium, you get it? It's not even sodium, it's sodium sulfate. It's not sodium. Even if it was sodium, sodium's not a diatomic element. Every year I have people do that. They'll put N2. What? So go ahead. Are they ions or not? Are they +1 ions or not?
Yes.
And are they aqueous? Let's move on, go.
Plus sulfate, just 1.
What now?
I put just 1 sulfate.
Right.
Aqueous.
But wait, is it an ion? Right now it doesn't look like an ion.
-2.
There you go. Keep going.
Plus PB aqueous +2.
Like that? +2? Okay, it's an ion, isn't it?
Plus NO2, NO3 aqueous.
Is it an ion? Are you going to put -1 there?
-1.
All right, keep going.
And then it should be
Say it again.
2 sodium
Sodium what?
nitrate.
Sodium nitrate?
Oh, sodium aqueous.
Aqueous? Is it an ion? It doesn't say ion. Is it an ion?
Yes.
So I need to put +1, don't I? What else?
Plus 1 nitrate.
How many?
1.
How many?
1.
How many?
2.
That's what I thought you said. See, because that 2 is 2 sodiums and 2 nitrates, isn't it?
2 aqueous.
Okay?
Plus PbSO4. And it's a solid.
Nice. That's very good. And you know what? Can I tell you something? If you happen to not do this well, like for example, see where it says 2 sodiums here? What if you only had 1 sodium here? You made a mistake. If it's a spectator ion, you had 2 here and only 1 here, you made a mistake. What about here? She almost made a mistake. She said there were 2 nitrates here, but she thought there was only 1 here. No, that's not going to happen. All right, you did a good job, all right? Let's have, who do you want to pass the ball to, okay? Pass it to somebody.
Caroline.
Carolyn, okay, who am I going to cross out? What are the spectator ions? Sodium? You didn't do anything.
Nitrate.
Okay, so now go ahead. What's the only chemistry that actually happened? Real loud. Is it an ion? Is it dissolved in water?
Plus lead, the ion plus 2 aqueous. Yields lead sulfate.
Lead 2 sulfate?
Yeah,
And what do you put to that?
to the solid.
Wow, what do you think? I bet the first time you saw this, you said, I can't do that, but you can do that, can't you? I'd like to show you, I am going to ask you to do this on the test. I will ask you to do this, okay? And it's a skill, and you said, I know how to do it, but can I show you also later on the multiple choice part? Can I show you how to save a whole lot of time? Would you estimate how long it took you to do this problem? I estimate 3 minutes, is that right? Can I show you how to do this whole problem in 15 seconds? Now, on the one part of the test, I'll make you do the whole thing. You get it? But if I'm doing the multiple choice part, they'll say, which of the following is found in a net ionic equation? I don't want to spend 3 minutes to do it. I'll show you a shortcut. All right, here we go. Ready? Here's the next problem. Now, all I want to do is write this down. After I write it down, I'll show you how to do the shortcut. KOH aqueous plus iron 3 nitrate. Okay, so KOH plus iron 3 nitrate, and I'm going to write that down. Here we go. KOH aqueous plus iron 3 nitrate. Okay, now, after I have it written down, I'm going to show you how we can do this in probably 15 seconds. You ready? Are you ready? You don't believe it, do you? You don't believe it. Okay, first of all, I'm going to do something kind of weird, all right? In my head, this is aqueous. In my head, I already know the two products are what? Iron 3. Wait, you got to be able to do this. It's double replacement. The two products are iron 3 hydroxide and potassium nitrate. Are you going to look up potassium nitrate? Are you going to look it up? No, it's soluble. It has to be spectator ions. But what about the iron 3 hydroxide? Are you ready? Start the clock. Go. Iron 3 hydroxide. Iron 3 hydroxide. Iron 3 hydroxide. Iron 3 hydroxide. Whoa, wait a minute. I missed it. S. Here we go. Iron 3 hydroxide. S. We're going backwards. What is the only way? What's the only way you could have made iron 3 hydroxide? You had to have 1 iron 3 ion. I'm going backwards. Plus what? Look. 3 hydroxide ions. I'm done. That is the net ionic equation for that thing. One more time. I knew the two products are going to be potassium nitrate, but that's soluble. You're all spectator ions. And what's the other one? Iron 3 hydroxide. So I wrote down iron 3 hydroxide. What's the only way you could have made that compound? I need 1 of those ions and 3 of those ions. That was pretty fast. Want to do another one? Let's do another one. Let's see how fast you are. All right, let's do, all I want is the net ionic equation. All I want is the net ionic equation. You don't even have to write it down. Don't write it down. All right, write the net ionic equation down, but don't write the equation down, okay? Let me go over here. Watch it. Watch on. Whoop, too fast. Too far. Hey, ready. Go. Don't write that down. Don't write that down. What are the two products? Potassium chloride. All potassium salts are soluble. No. What's the other one? Barium nitrate. Barium nitrate. What? Anybody? Yes. What now? So there's no net ionic equation. What does that mean? So what does that mean? Huh? It's a big NR. What's NR mean? No reaction. You can put these chemicals together. You know what? Nothing's going to happen. Nothing is going to happen. Last chapter, what would have happened? Last chapter, you would have written it down. You would have balanced it and said, yeah, it's going to happen. Guess what? It's not going to happen. All right, let's try another one. Okay, I like that one. All right, ready? Very fine. I want to know the net ionic equation for number B, letter B. Okay, ready? I'll give you 30 seconds. How about that? Ready and begin. Write the net ionic equation for letter B. And if you can't, that's okay. We'll practice it again. We'll do it again. Raise your hand if you actually have it. Ooh, only 2, 3. Ooh, you guys are fast. You're fast. I have in the test 6 questions in a row that are like this. It says, this reacts with this. It says, if a precipitate forms, write the formula of the precipitate. That's all. That's all it says. Another question will say, write out the net ionic equation. So here we go. All right, can we do this? All right, so what, oops. Are you ready? Who wants to do it? Oh. Madam, you can do it. Madam, tell me the 2 products. Go.
I don't know.
That's fine. And thanks for being honest. That's very important, okay? Everything we're doing here is double replacement. Is that right? Everybody know that? Double replacement? So what we're going to do here, sodium is going to kick copper out and make sodium nitrate. Copper is going to kick sodium out and make copper 2 sulfide. Did I get that? Okay, now, so one of the products is going to be sodium nitrate. Is that a precipitate? What do you think about that one, Madeline? You can look it up, or you can remember all sodium salts are soluble. All nitrates are soluble. He can't be a precipitate. Must be spectator ions. What's the other one? If sodium kicked copper out to form a compound with nitrate, copper is going to kick sodium out and form a compound with the sulfur. So what's that going to be? How does copper, and by the way, which copper is this? Copper 1 or copper 2? Right, that's right. So here we go. Copper 2 is going to form a compound with sulfur. And sulfur is -2. Look at the periodic table. It's -2, isn't it? And if you look it up, what do you find? Look, copper sulfide is a solid, isn't it? Solid? So here we go. Watch now. I'm ready. Isn't that right? What's the only way you could have done this? What's the only way you could have made this? How many copper ions do I need? Go ahead, madam. In order to make this compound, how many coppers do I need? And it had to be an ion, right? AQ. And what else did you need? What else did you need? I needed one of those ions, and I needed what? How many sulfur ions do you have? How many? Look at the formula. How many sulfur ions do you see? I say 1 copper. 1. There we go. We're done. Everything else was a spectator ion. That's the only chemistry that took place right there. All right. What I'm going to do now is, I'm not shifting gears, but I want to show you the same idea, and I think you're going to be surprised. So far, here's what you know. Double replacement reactions could be called precipitation reactions, because what is the driving force? Formation of what? Of a solid. Now, there's another kind of double replacement, so we can use the chart if we want, and this one is going to be called acid-base neutralization. And all this is in your book. I'm just here to teach it to you, okay? And in this case, the driving force is going to be the formation of water. All right, here we go. All right, what is the most famous acid in the world found in your stomach? Oops, I guess it's not that famous. Anybody know? All right, what happens when you add hydrochloric acid to the most famous base in the world? What's the most famous base in the world? not counting Fender or Stratocaster. I made it up. That's a bass guitar. What do you think? What's the most famous bass in the world? Oh man, sodium hydroxide. Okay. All right, do it. Ready? Do that. Double replacement. Whoop, 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 whoop. Try it. Write out the whole thing. Write out the whole equation. Write out the complete ionic equation. And whoa, you can't even see this. There you go. Write out the net ionic equation. Should be getting a little faster at this. All right, see if you can beat me. All right, ready? I'll start now. HOH and NaOCl and this is water. That's liquid. And I look, all sodium compounds are soluble in water. And oh, it's already balanced. Okay, now complete ionic equation. Is everybody, are you ahead of me? Is everybody ahead of me? Don't let me catch you. Ready? Don't let me catch you. Hydrogen ions plus chloride ions, dissolving water, plus sodium ions, plus, am I catching you? Give you a little chance to get ahead of me. Whew. Now what? Now what? Ethan, what do you think? What is this going to drive this reaction? All acid-base neutralizations are driven by the same driving force. What's going to be right here?
Formation of water.
Yes, the formation of water. Instead of a precipitate, in this case, it's water that's being formed. And what's next? What's going to happen there? See, look at it. How do you write that? Dissolved in water?
Yes. Plus Cl equals
Ion? Ion? Is this an ionic compound?
yes.
What's it made of before you put it in water? Starts with I. What's an ionic compound made of before you put it in water? Ions. And this was aqueous, right? So now we have sodium ions and what? Chloride ions, right? All right, ready? Cross out the spectators.
Let's see.
You tell me.
Chlorine.
Yes. You didn't do anything.
Sodium.
What's the net ionic equation for every acid base? The hydrogen ions bump into what? Hydroxide ions, and what do they form?
H2O.
Yep. That's it. Now, you know what? If you have a solution that has an excess of hydrogen ions, it's an acid. What if you have a lot of hydroxide? You're a base. But what if, look at this right here, look. What if for every one of these, there was one of those? What if you had 1,000,000 trillion of these and 1,000,000 trillion of those? You'd have 1,000,000 trillion of what? What would they turn into? 1,000,000 trillion waters. Now, would I be acid or would I be base now? Or would I be neutral? Everything would be neutral, wouldn't it? And that's why I call it neutralization. All right, well that's, by the way, I could have used this chart, but the only thing here is the formation of water, okay? All right, so here's what you know so far. Of the double replacements, we now know a little bit more than we did last chapter. We now know there are two kinds of double replacements. One of them is a precipitation reaction because the driving force is formation of a solid. And what's the other one called again? What's the other double replacement? Acid-base neutralization, and it works because you have the formation of water. Okay, now, what I'm going to do is I'm going to get into the hardest part of the chapter today. Now, this is only Monday, right? If the test's not till Friday and we get into the hardest part right now, we'd have time today. We'll have time on Tuesday, maybe even, Wednesday, Thursday, talk about it again. And what I'd like to do is, wait, this is not the hardest part. Let's do one more, then I'll do the hardest part. Okay, now, since we just talked about acids and bases, when you had to name compounds, you know what acids look like, don't you, on a formula? Look at this one right here, right? Now, of all the acids we wrote, there are these acids that are called strong acids, and here are the only three I want you to know. Every first-year chemistry student knows that there are three, they know at least three strong acids, and what are they right now? What are the names of the three strong acids that a first-year chemistry student should know? What's it? Hydrochloric acid, yes. What's another one? Somebody else? No, Ramos, I haven't called on you. No, what do you think? What's another strong acid? The first one was hydrochloric acid. We already did that one. What's this guy called? What's HNO3? I think we forgot how to name acids. Yes. All right, Kayla, what's the third one? H2SO4. Sulfuric, very good. Now, so if I ask you about three strong acids, there they are. Now, what makes them strong? What makes them strong is that if you put any amount of this in water, 100% of them will break up and separate into ions. 100% of them. What if I had a little bit of HCl and I put it in water? 100% of them will break up into H and Cl. What about nitric acid? Put any amount in water, 100% of them will go H, NO3. See it? Now, the only weak acid your book even talks about here, where am I at here? The only weak, as a matter of fact, in first-year chemistry, they don't talk about it too much. The only weak acid that most first-year chemistry students know about is this guy here called HC2H3O2. What's that called? What acid is that? It's found in vinegar, acetic acid. Now, I didn't do the experiment, but every book I read said, if you put this in water, did you know only one out of 100 will break up into ions? Wow, that means a lot of them kind of stay around here. It's like, I win, not all the time. 1 out of 100 times you break up into ions, and that's why you're not called a strong acid. Now your book links these two. It says, let me ask you this question. Would a strong acid be a strong electrolyte? This we gotta wake up a little bit, okay? What is that makes electricity flow through that thing? What makes a strong electrolyte? Ions. What if you're a strong acid and 100% of you break up, then you're a strong electrolyte? What about weak acid? Only 1 out of 100 turns into ions? Well, the light bulb's not going to come on very high for you. Get it? Weak electrolyte. How about bases? What's a base? For first year chemistry, it's usually group 1, group 2 hydroxides. Okay? Think one. Lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, sodium hydroxide, beryllium hydroxide, magnesium hydroxide, calcium hydroxide. See? It's usually group 1 and group 2 hydroxides. Now, your book, I think, only mentions potassium hydroxide and sodium hydroxide. I think that's all they have. Yeah, that's the only ones they mention. You get it? That'd be pretty easy. Now, why is it called a strong base? If you put NaOH and in a water, 100% of them will break up into Na ions and OH ions. 100%. Strong electrolyte also. Okay, that's enough of that. Anyway, if you want to read that, you can, and that's not the hard part of the chapter. Now, here we go. I can promise you one thing. What we're going to do next is the hardest part of the chapter. I can promise you that you probably won't catch on today. I can tell you that on Wednesday, you'll catch on a little bit, and you'll get better at it. And on Thursday, you'll catch on, but you know what happens? By the time you hear this again, you might get it. But I think you could do well on it. So let me tell you about this. So here's my little device here. Tell me about the kinds of reactions. Let's see, we said double replacement, single replacement. What's another one? What is it? Yeah, synthesis, what else? Okay, one more. Huh. Okay, guess what? There are two kinds of double replacement. What are they? Precipitation reaction, and the driving force is formation of a solid. Acid, base, neutralization. And driving force is what? Formation of what? Water. Okay. Now, for the first time, I want to show you something. All of these, none of those are double replacement. Get that? None of them would I use this chart for. None. I only use this chart for precipitation reaction. Get that? All of these have the same thing or drives them. Okay? So, we have a fancy name for this, and I'll show you how, a little memory trick here. I had somebody who was a valedictorian last year of this school. He went to NC State, and he doesn't like, he's very modest person. He wrote me a letter, and it's very nice. He said, things are going well. He wanted to thank all the teachers, and he wanted to thank me about different things. He said in his chemistry class at NC State, there were 535 people. And he ended up being number 5 out of 535. He had 102 average in chemistry. And he said, and I'm even sharing some, and this is not about me, he's sharing some of the tricks he learned in here. And he said, this is the one he learned. He said, even the Leo says grr. Now, you don't know what that means yet, okay? But he happened to remember that Leo says grr. Now, what I'm going to do is I'm going to show you this little memory trick. Now, here's what happens. When you have a transfer of electrons, somebody has to lose electrons and somebody has to gain them. You get that? You cannot have something losing electrons unless another chemical is there to gain them. You get it? So we have Leo, ready? If you lose electrons. Now remember, losing negative electrons, think about it. If you lose negative electrons, you are oxidized. You can become oxidized. Okay. If you, and that's Leo, L-E-O, okay? If you lose electrons, you got oxidized. If you gain negative electrons. Oh, by the way, let's do it again. If you lose negative electrons, you get oxidized and you become more positive. What if you gain negative electrons? What happens to you? We say you are reduced. You're reduced and you become more negative. Okay, now, so here's a chemist, and they came up with this thing. Hey, what's the driving force? Transfer of electrons. Some people gain, somebody loses, all right? And then, so they had to say, well, what are you going to call these reactions? I'm going to call it the oxidation-reduction reactions. Oxidation-reduction reactions. Hey, what kind of reaction? Oxidation-reduction. Well, we're humans, right? And just like we don't like saying deoxyribonucleic acid all the time, what do we say? DNA. I don't know. Maybe it was some chemistry party on a Friday one night, and they said, I hate saying that word. Oxidation-reduction. Oxidation-reduction. What do you want to call it? Somebody said, how about redox? Yay! Okay. So what does redox stand for? Reduction Oxidation. It's a fast way of saying it's an oxidation reduction reaction. These are called redox reactions. I'm looking at your faces. All right, I promise you, if you went back over these, all these right here, if you went back over these, nobody would have changed their charge in those reactions. Nobody. If sodium stardate was +1, H2O was +1. Nobody. These are not redox. What's the only ones that are not redox? Double replacement. All the rest of them are redox. Okay, you did a good job. Now, what I'd like you to do is, if you haven't been working on your homework and you haven't been reading the book, that's your job, start doing that. By the time you come Wednesday, if you want to read this section here, 7.5, if you'll just try reading it, you'll say, I think I'm getting the hang of this. I'll spend all day Wednesday doing redox. That's all we do. And we'll be done. We'll be done with the chapter when I get done with redox.